Okay, so we've got here two objects attached by a string, okay, over a pulley system here. So there's sort of possibility then for these objects to move, okay, but because they're attached, they'll sort of move as one system, okay. Now let's write in a few forces, okay. Well, we know the block of A has mass 3 kilograms, so the weight will be 3g, okay. And we know the block of B has a mass of 5 kilograms, so the weight will be 5g. Because it's sitting on the table A there, and it's going to possibly move now in a moment, okay. Of course, vertically there's no movement, okay. There's no movement because the table and is supporting that weight, yeah. So there's a reaction here, which is going to equal the weight here. So straight away we can say like R is equal to 3g, okay, because vertically the resultant force is 0. Okay, resultant force is 0 vertically. But if you read this question, then it says that a horizontal force of magnitude 75 newtons is then applied to A. So object A, there's a force applied to it of 75 newtons. So it's being pulled, right? The question is in which direction? Well, it says in the direction PA. Okay. Now this is just like vectors. If you think about the direction PA, it starts at P and and goes to A. So PA means sort of going in that direction. So it's being pulled in that direction. So in other words, the object is going to be accelerating in this direction here. So we'll draw that force in 75 newtons. Okay. And then we'll appreciate then, because it's moving, because there's a force applied this way, it's the potential is then for A to move in this direction, and that's where it says happens, because it says B is raised, yeah. Now, in order for B to be raised, A has to move to the left, yeah. So it's sort of pulling it. Now we're not quite done with all the forces, because you've got to appreciate there's a string here, and if you think about object A to start with, right, it's been sort of pulled in this direction, okay, by that force of 75 newtons. But when it's being pulled in that direction, there's sort of something slowing it down, isn't it? This string is sort of pulling back, if you appreciate, yeah. So even though you've got this force pulling it to the left, this string is pulling it back because this weight is attached here. And the force of that string is called the tension, yeah. It's tension in that string, okay. And I'm sure you can see the reason for that, yeah. It's like a resistance to object A when it's being pulled to the left, because it's obviously this string is pulling up this object B. And the thing is then, you've also got to see then that B is moving up, so it's accelerating that way. Now when you look at B, the only force I've got acting on it at the minute is the weight. Well, that's no good, isn't it? Because we're told it's being raised upwards. So what's actually pulling it up? If you think about it, it's the string, isn't it? It's the string that's pulling it up. And in the string, we've got this tension T, okay? And we'll learn later on, okay? We'll come to realize that the tension in the string is the same throughout, okay? Just sort of accept that for now. It's the same throughout. So this T here is the same as this T here. So all you've got to do is you've got to apply Newton's second law. And if we do that, we can then work out the acceleration and the tension. So when we apply Newton's second law, well, if we look at A to start with, right? Vertically, we've already established vertically that R is equal to 3g, okay? Because the resultant force is 0. Horizontally at A, so I'm focusing, when I say at A, I'm on about object A, right? So if we apply Newton's second law there, well, the resultant force is not equal to 0. The resultant force is equal to mass times acceleration. Okay, that's Newton's second law. Let's think about what the resultant force is. You've got a force going this way and a force going that way. Which is greater? And you just got to appreciate, because it's being pulled this way, that's 75 newtons. It's got to be greater than the tension, because it is overcoming the tension. It is managing to move. So that's going to be greater. And then of course you take away to get the resultant force, you take away the resistance then, okay, to see what you've got as the overall resultant, moving it to the left. That will equal to then the mass. Now the mass, remember now we're looking at object A. So I said here, the mass of A is 3 kilograms. So 3, and A then, okay, is the acceleration. Okay. Now we don't know what t is, and we don't know what the acceleration is. That's what we're trying to find out. Find the magnitude of the acceleration of A and the tension in the string. But what we can do now is we can go to B. Okay, and if we look at B, we can resolve vertically. There's no need to resolve horizontally at B, okay, because there's no movement horizontally, but vertically there's movement. It's going upwards. So the resultant force, well, because it's going up, T has got to be bigger than the 5g. So T take away 5g. That's the resultant force. That's bigger than this, equals to mass, which is 5. The mass of B is 5 kilograms, so 5A. So look at what we've got here. We've got 75 minus T equals 3A. And then we've got T minus 5G. Well, remember 5G is just 5 times 9.8. Because G is 9.8, so that'll be 49 equals to 5A. So we want to find T, we want to find A. What do you think we're going to need to do here? Think about it, of course, it's simultaneous equations. So with simultaneous equations, we solve them. And you know what, it's really easy to do this because all you've got to do is add them. Literally, you just add them. Because what happens when you add them, they will cancel out. Minus T, add T is 0. Okay, so if you just add equation 1 and 2. So if you want to call this equation 1 and 2, you're just literally adding them. So if I add them, minus T add T is 0. 75 add minus 49 is 26. And 3 add 5 is 8, so 8A. So to get A, you just got to do 26 divided by 8, yeah? So my calculator, I get 3.25 meters per second squared, okay? And it really is as simple as that. And then to get T, you just need to sub it into one of these, sub it into 2. So sub into 2. T minus 49 is equal to 5 times A, which is 3.25. So T will be, well, 5 times 3.25 is 16.25, plus then 49. So I get 65.25.